is your lesson on tangent lines. This is a really important lesson. We are now transitioning more into calculus. The first understanding of calculus is it starts with limits. And when it's about limits, that's calculus, that's Newton. Here's the next level up in terms of understanding limits. Like, why do we need to know limits other than just knowing how to find them? And this is going to guide us into why we need to know limits. So what our goal is today is to find the slope of a line that has 1 point on a function. Now, when something touches with 1 point, we call that a tangent. When something touches with 2 points, that is called a secant. So do you see that word secant? So 2 points touching the graph, secant. 1, that's called tangent. Now, if I have 2 points, I want you to make sure this is clear to you, that secant is algebra. And it means to find the slope with the slope formula. So if you have 2 points and asked to find the slope, you would go y2 minus y1 and x2 minus x1. That is how you would find the slope. 2 points, algebra, what we've done for years. So that's secant. What makes this algebra to calculus is what happens if you only have 1 point. So now there is no difference here, and there is no difference here. So when there's no change in y and no change in x, what happens? This is that indeterminate part, 0 over 0. And how do we do that graphically, 0 over 0? And the answer is, to find the slope with 1 point, we have to create a limit. So when I actually get there, we have 0 over 0. It's indeterminate. But what we're looking for is what's the answer as we are approaching 1 point. So when you look off this graph, you have 2 points in a secant line. And then you have another line with 1 point. And so what we are doing is we're taking a point on that graph. So a point would be x and f at x. And then we're finding a second point on the same function. And to do that, we're calling it h. So we're just adding a number to x. So we add a number to x to get another point arbitrarily. We're just calling that h, whatever that is. Then if you do that to the x, you also have to do it to the y coordinate, add that same number. And we create a limit saying, what's the limit as it's approaching 0? We know when it's equal to 0 that it's the same point. And it's hard to find the slope, right? It's indeterminate when it's exactly there. But as it's approaching 0, what's the answer? And that concept of a limit, and as it's approaching 0, gives us the slope with 1 point. So we're not looking when it gets there, but we're getting so close that we can get an answer as it's approaching. So again, 1 point is tangent, 2 is secant. We're finding the slope of the tangent line by starting with the secant line, and we're going to get closer and closer and closer to 1 point. So think of this. This is like a little formula we're going to use. That is y2 minus y1 and x2 minus x1. So what's the y coordinate? It's f at x plus h. What's the other y coordinate? F at x. See, y2 minus y1. How about here? I don't see it. Well, the other one is the x coordinate, x plus h, subtract x. So if I have x plus h and I subtract x, that's x2 minus x1. Look at the x coordinates. Well, what happens to the x's when you subtract? Well, when you subtract, the x's combine like term and leaves you just with what? H. Now, if I plug in 0 here, it's indeterminate. So we don't want to plug in 0. We want to find the limit. And then how do I find that limit? Is either through algebra and factoring or by doing the conjugate. So let's do the work right now using this right here. So we want to find the slope of the tangent line. So let's write it down. That's the limit as h approaches 0. Now y2 minus y1. So we're going to write it in this fashion. So y2 minus y1 And then x2 minus x1 just leaves me with h. And you can also think of it as a formula that you need to remember, but know where it comes from. Now, in this situation, we now can substitute in. So we actually have a function to substitute in. So what is our function? It's up here, x squared plus 1. So I'm going to write down f at x plus h. We know what x equals, which is negative 1. We don't know what h equals. So we're going to plug in negative 1 for x. We have h, we don't know that one. In fact, we know it's 0 at one point. Again, we're going to plug in negative 1 for x. And then the denominator I don't know. Again, I want to be able to plug in 0, but it'll be indeterminate if I plug in 0 right now. So we're going to continue the limit as h approaches 0. We're going to simplify. So negative 1 plus h, I can't simplify. So I'm going to take it, I'm going to substitute into here. So what's f at negative 1 plus h? I'll take out the x, put in negative 1 plus h squared plus 1. That's what this is right here. So take out the x and put that in. Subtract. Now it's negative 1. So if I plug in negative 1, what's the answer? Well, negative 1 squared is 1 plus 1 is 2. So I can put that in. And then we still have an h in the denominator. Notice we're not in any position yet to plug in 0. It's still indeterminate. Let's do some algebra now. I need to know how to multiply that out. So if you want to, you can draw a little box. And that's negative 1 plus h, negative 1 plus h. I'm going to give you a hint in terms of expanding a binomial quickly because it happens so often. It's nice to have a little skill to expand it. So I'm going to do it that way. What's negative 1 squared? That's positive 1. What's negative 1 times h? Negative h, and then double it. That's negative 2h, and then h squared. And that works every time. So when it comes up and it's a binomial being squared, I'm going to do that. Notice I'm still writing down the limit notation, and I'm simplifying. So now I'm getting closer to the end here. So combine like terms. I have h squared. I have negative 2h. And I have 1 take away 2, which is negative 1. Oh, I forgot. There's also a plus 1 here, isn't there? And I forgot the plus 1. I'll put that in front. So 1 plus 1 take away 2, this whole thing eliminates. And I'm just left with h squared minus 2h. Now we're going to factor. So can you see how we're going to factor out the h? So in the numerator, factor an h out. That's h subtract 2. Now we're in a position to divide out the h. Now the whole is gone. Now plug in 0. And what's the slope at that point? And the answer is negative 2. Using a limit to find the slope with 1 point. All right, let's try it again with number 2. So step 1. How do I find that slope? It's a limit question when it's 1 point. So the limit as h approaches 0. And we're using that x value, negative 3 and 7. So this is the little slope formula we're going to use to find it with 1 point, or to find it. Then I'm going to substitute in. So I can't put in 0 for h, but I can put in the x value, which is negative 3. So I'm going to put in the x coordinate, negative 3. Now I need that function, and I need to do some algebra. So to do this algebra, I have a function x squared plus x plus 1. So take out the x and put in negative 3 plus h. Then we're going to do the same thing here. We go subtract. Now f at negative 3. So if I plug in negative 3 for x, that's 9, take away 3, that's 6, plus 1, that's 7. So I put in 7 over h. Some more algebra. I want to expand this. So I'm going to do what I did before. You can write a little box if you want to, but I'm going to go the quicker method. Negative 3 squared is 9. Negative 3 times h is negative 3h, and then double it, and then h squared. We still have a negative 3. We still have a plus h. And I'm going to combine like terms here. We have 1 take away 7, which is negative 6. And that's all over h. Still the limit notation. Now I'm going to combine like terms in the numerator. So 9 take away 3, 6 take away 6. That's 0. So we no longer have a constant. They are eliminated. I have an h squared, and I have negative 6h plus h. That's negative 5h when I combine like terms. I still can't plug in 0, but now I can factor. So it should be a lot simpler now. Factor out the h in the numerator. That's h subtract 5. Now we can divide out the whole. Now we can substitute in. Now we know the answer is negative 5. All right, number 3. We're starting to do some heavy lifting here. Can you find the slope with 1 point? So we're going to start with our little slope formula. The limit as h approaches 0 of f at x plus h, subtract f at x, that's y2 minus y1 all over h. We are going to keep writing the limit notation. The x coordinate is what I'm looking for. So the x coordinate is 2, so it's 2 plus h minus f at 2 all over h. Next, we're going to do a substitution. So we're going to plug in 2 plus h. We're going to have some fractions within fractions here. So instead of x, we put in 2 plus h. And a negative is going to make this plus. And again, I'm going to plug in 2 here, so that's plus a half. And then that's over h. Next, we need to make this one fraction in the numerator. So how do I do that? Well, I'm going to take the bottom of 1 times the top of the other. So what I'm going to do is the first denominator needs a 2. So top and bottom times 2 to make them the same. The second denominator needs 2 plus h, top and bottom, to make them the same. And then I'm just going to combine like terms. So we have negative 2 plus 2. That's 0. And then we still have a positive h when I combine like terms. And the common denominator there is 2 plus h. And that's over h. Again, some heavy lifting with algebra. How do I divide fractions? Is I multiply times the reciprocal. That's 1 over h. And then notice the h's divide out. There's the whole that divides out. Now what I'm left with is 1 in the numerator. Plug in 0, and you get 2 times 2. So the slope at that 1 point is 1/4. All right, turn the page. Let's do that one more time. Can you find the slope at that point? So to find the slope using 1 point, it's the limit as h approaches 0 of f at x plus h, subtract f at x, all over h. So there's our little slope formula. In our question, the x coordinate is negative 2. So it's negative 2 plus h, subtract f at 2, negative 2 I should say, all over h. And now do the substitution. So go back and go, okay, take out the x and put in negative 2. In this case, it's negative 2 plus h. Same thing here, subtract, plug in negative 2, And negative 2 plus 3 is 1, and 1 divided by 1, that just gives you 1. And that's over h. Keep going. Each step should feel like it's going to get a little easier. This is going to be the toughest step. Can you make common denominators? Well, if I combine like terms here, this is h plus 1. So it's 1 and h plus 1. And then I'm going to change 1 so it has the same denominator. So that's going to be h plus 1 over h plus 1. That way they have the same denominator, and this is still 1. So now I can write it as one fraction. So combine the numerators. 1 take away 1, it's done. So I just have h over h plus 1 over h. Next, you multiply times the reciprocal of the denominator. Notice the h's divide out. Now you can plug in 0. So you have 1 on top, plug in 0, 1 on the bottom. So the slope there, okay, leave a negative here. So notice I have subtract h. So I have 1 take away 1. This should have been negative h. So I'll make that correction really quick. That leaves you with negative 1 when you divide out. So that means this answer here was negative 1. All right, next part of the lesson. Now, next part of the lesson is to write the equation of tangent lines. I do not want you to write it this way, so we're not going to do that. So instead, we're going to remember the HK form of a line. So the HK form of the line is the simplest one to work with for the tangent line equations. And that's y equals the slope, and it's x minus x1 plus y1. Now this does come from the slope formula, y1 minus y and x minus x1. So this is that slope formula, but it's written in a form to very easily write an equation of a line. So let's go through the steps to be able to do that. So the first thing I need to know is the x coordinate is 1, the y coordinate is 3. So that's wonderful. You actually don't need to be given the y coordinate. You could have plugged in and also find the y coordinate. But here is what I need to know to write the equation of that tangent line that's touching the graph at one point. I need to know the slope. So I need to do the work that I just did, but do it here for the slope. So to find the slope, it's the limit as h approaches 0 of f at x plus h, subtract f at x all over h. In our situation, the x coordinate is 1. So we're going to put that in. So that's f at 1 plus h, subtract f at 1 all over h. We're going to continue with that. So now we're going to do a substitution. So notice 2x squared. So 2, now instead of x, we're putting in 1 plus h plus 1, subtract. Now, if I plug 1 into here for the second part of the numerator, that's 2 plus 1, which is 3. So that's where that comes from. That's over h. So we're just going to continue the algebra here so we get our answer for the slope. So to continue that, we're going to multiply this out with the 2 in front. So 1 plus h squared is 1 squared. 1 times h is h and then double it. And then h squared is h squared. That's expanding that binomial being squared. And then 1 take away 3 is negative 2. We're going to continue to combine like terms. So when we combine like terms in here, I get 2 times 1, which is 2, take away 2. So they eliminate. 2 times 2h and 2 times h squared. So 2h squared, 2 times 2 is 4h. Next, I'm going to factor out an h and a 2. So we have 2h. That leaves me with h plus 2. Divide out the h's. Then I can plug in 0. And what I'm left with is 4. So what's the slope here when I plug in? So now I know my answer. I got x, y, and I have the slope 4. So now what's the equation of the tangent lines? We write y equals, the slope is 4, the x coordinate, we do the opposite sign and then keep the sign for the y, and there is the equation of the tangent line. All right, let's try that again. Number 6. Can you find the equation of a tangent line? So the x-coordinate is -3. The y-coordinate is 1/4, but it's the slope that I don't know. So to find the slope, it's the limit as h approaches 0. Here's the formula that I'm going to write down to find that slope. So I'm going to plug in x plus h. So it's -1. Then it's x plus h minus 1. And then I'm going to plug in, oh, we know x. So what's x again? -3. So I can plug in -3 here. And again, I can plug in -3 here, all over h. So let's clean this up a little bit. So if I plug in -3 here, I get -3 subtract 1, which is h minus 4. If I plug -3 into here, we already know the y-coordinate, and the y-coordinate is 1/4, so that's helpful. So subtract 1/4, and that's all over h. Then the limit as h approaches 0 here, keep doing the math, I need common denominators. So the first denominator needs a 4 top and bottom, so that's -4. The second one needs an h minus 4, so I'll do that top and bottom. That gives me a -h but a plus 4 if I do that correctly. And then the denominator is 4h minus 4 all over h. Again, some heavy lifting with algebra. So the limit as h approaches 0 here, combine like terms, -4 plus 4, that gives me -h, and then 4, h subtract 4 in the denominator over h. Next, notice that we're going to go times the reciprocal of the denominator. And the h's divide out, and then plug in 0, and you get positive 1/16, because the negative and the negative makes it positive 1/16. So now we have what we need. So what's the equation of the tangent line? So what's the slope? 1/16. What's the x-coordinate? X plus 3. And what's the y-coordinate? Plus 1/4. Done. All right, number 7. So write an equation for the slope of the tangent line to the function at any point. Then use the equation to find the slope of the graph at x equals 4. So we're not starting with a point here. So to do this one at any point, we don't have an x value yet. But they said use the equation to find the slope at x equals 4. But let's first find the slope with actually not having an x value to start with. So it's still a limit question as h approaches 0. It's still f at x plus h subtract f at x all over h. When I substitute in, I have x and h that I need to worry about. So when I do that, it's x plus h squared. Subtract 2, x plus h. Subtract 2, and then I subtract, and now I just write down what the function is. I'm going to use parentheses. So f at x is this. X squared subtract 2x subtract 2. And again, that's all over h. Next, I have some algebra to do for sure. So let's do that algebra. It's going to be a long fraction line here. So what's x plus h squared? So that's x squared plus 2xh plus h squared when you expand it. And then we have subtract 2x and subtract 2h, and then subtract 2. Then make sure that subtract sign belongs to the x squared, and a negative makes it plus 2x, and a negative makes it plus 4. No, a negative makes it plus 2. So where did I get 4 from? All right, and that's over h. Now, if I did this correctly, anything that does not have an h in it will be eliminated. So x squared and negative x squared, they're eliminated. H's, we're going to combine like terms, but negative 2x plus 2x, they're eliminated, and negative 2 plus 2 are eliminated. So then what does that leave me for the slope? So we have the limit as h approaches 0, combine like terms. We have 2xh, we have h squared, and we have a negative 2h. Now we're going to factor out an h out of everything. So if I divide an h out of everything, I have 2x plus h minus 2. So I take an h out of everything, divide it all out. Now I can plug in 0 for h, and I have 2x subtract 2. For any x value now, I can use that to find the slope. So for our situation, we said x equals 4. We're not given the y coordinate, so I got to plug that in, 4. So that's 16, take away 8, take away 2. That's 6. And the slope, I got to plug in 4 in here too. So if you plug 4 here, 2 times 4, 8, take away 2, that's also 6. So the slope is 6 and the y coordinate is 6. So it says write an equation for the slope of the line tangent to the function. So the equation, the slope is 6. The equation of the tangent line would be y equals 6, x minus 4 plus 6. All right, number 8. We got 2 more to do. X cubed. So to find that slope at any x value, the limit as h approaches 0, f at x plus h, subtract f at x all over h. So there's your little slope formula. Next, we're going to plug x plus h into here, cubed minus f at x. So that's just x cubed all over h. Now, this one's a little bit more challenging. So let me do this on the side. So this is x plus h and x plus h squared. So we know that's what x cubed is. This second part is x squared plus 2xh plus h squared. If you expand the second part, then when you draw this out, you could also use Pascal's triangle, but we're doing this. It's going to take a moment because it's a cube. It takes longer to expand. So that's x cubed. In fact, I'm going to put the answer right in here right away. So the limit as h approaches 0. X times x squared is x cubed. X times 2x is 2x squared. H. This one is x h squared. This one is x squared h. This one is 2x h squared. I have some like terms to combine together for sure. And then h and h squared is h cubed. And then we have a subtract x cubed that's already here at the end that I need to include all over h. All right, combine like terms. If I did this correctly, only terms that have an h in it are left over. So x cubed, does it have a partner to subtract out? Yes. Anything else that has only an x or h in it. So that's only the one. Now everything else has an h in it that I need to worry about. So 2x squared h. X squared h, that is 3x squared h. X h squared, 2x h squared, that's again 3x h squared. And then finally, I have an h cubed. So I'm going to divide an h out of everything. So if I divide an h out of everything, I have 3x squared. I have 3xh. and I have h squared. Now, in this situation, when you plug in 0, all you're left with is 3x squared. You now have a situation where no matter what the x coordinate is, you now know the slope. So our x coordinate for these is 4. If I go 4 cubed, that's 64. And the slope, if I plug in 4, well, 4 squared is 16 times 3 is 48. Now I can write down the equation of the tangent line. Y equals slope 48, x minus 4 plus 64. And you're doing some big time calculus, so I'm big time proud of you. Last question of the lesson. I know this is heavy lifting algebra. I'm not being fooled by this, but you're doing it with me and not alone, okay? So I want to find the slope of this. So it's the limit as x approaches 0, and we know it's f at x plus h, subtract f at x all over h. There's our little slope formula we've been using over and over and over again. In this situation, we're going to plug in 2 over x. So instead of x, I'm going to plug in x plus h. So it's 2 over x plus h, subtract f at x, which is just 2 over x over h. Here we need common denominators. So the limit as h approaches 0 here, the first denominator needs an x, top and bottom. The second one needs x plus h, top and bottom. And that leaves the common denominator as x plus h. So the first denominator, x, top and bottom. The second one, x plus h, top and bottom. And then we have common denominators, and this is what I'm left with. Now, I'm still going to simplify this. So the limit as x approaches 0. So 2x subtract 2x, that's eliminated. H is left. We have x and x plus h, and that's all over h. So the next step is to multiply times the reciprocal, which is 1 over h. Notice the h's will divide out. Now plug in 0, and what you're left with is 1 on top over x squared. Right? Where'd the 2 go? 2x. Oh, it should have been negative 2h. Haha. So if I cross it out, I'm left with negative 2. I conveniently didn't distribute there. Negative 2 over x squared. So now we have a formula to work with. So we're told the x coordinate is 4. The y coordinate, if I plug in, is 2 divided by 4, which is a half. And then the slope, plug in 4 here for the slope. Negative 2 over 16. You don't have to simplify. So the equation of a tangent line, slope, negative 2 over 16, x minus 4 plus 1/2. The equation of a tangent line. You guys are absolutely incredible. You got to the end of this lesson. This is heavy lifting, tough algebra, great calculus, and this hard work is so going to pay off. Mr. G Math, over and out. Until next time.